Hey everyone, we're going to slow things down a little bit and go back and take another look at lesson 6. We've been using the Pythagorean theorem a bit, but I feel like we just need a little bit more practice before we have an assessment. So our objective is to solve problems using the Pythagorean theorem. We've done just some basic algorithms, but now we're going to actually apply it to situations. So solving with right triangles, the Pythagorean theorem can be used to solve a variety of problems, and it's helpful to use a diagram to determine what part of the right triangle is unknown. So we've got our equation a squared plus b squared equals c squared. And what we have to determine is, are we looking for a, are we looking for b, or are we looking for c? So the first example here, it says write an equation that can be used to find the length of the ladder, then solve and round to the nearest tenth. So that being said, we'll look at the picture and I'll kind of talk you through here. So we're being asked to find the length of a ladder that would be used to access this building. One leg, the base here, that's 8.75 feet. The other leg that goes up the building vertically is 18 feet. And what we don't know is x. And it's called x because it's an unknown, but we know that that is c as far in relation to a right triangle and looking for the hypotenuse. So what we do is we write our base equation, a squared plus b squared equals c squared. We plug in what we know. We know one leg is 8.75, so we square that. We know the other is 18, so we square that. We work through the math here, square 8.75 to get 76.5625, and we square 18 to get 324. When we add those together, we get 400.5625. And then remember, right now, that value is c squared, and we want to know what c is. So to get that value c, we have to take the square root of this value, 400.5625. And when we do, we get about 20. And since the length cannot be negative, the ladder is about 20 feet long. So we also have to think about, in the whole scheme of things here, if we have one leg at 8.75, one leg at 18, does 20 make sense for the hypotenuse? And it does. If it said 200, that would probably mean that we made an error somewhere. For number 2 here, it says write an equation that can be used to find the height of the plane and then solve round to the nearest tenth. So very similar situation, except instead of knowing both legs, we know the hypotenuse here at 12 miles, so that's c. We know one of the legs, we can call this b. And what we don't know, I'm sorry, back up here. This is already labeled as b, so we'll call this a. So we know c, we know a, but we don't know b. So once again, all we do, we set up our base equation, a squared plus b squared equals c squared. I know a is 10 miles, so we take 10 squared. We don't know b, so we just put in b squared. And we know c, the hypotenuse, is 12, so we put in 12 squared for c squared. Again, we work through the math. 10 squared is 100. Bring down the b squared, bring down, and then 12 squared is 144. Leaves us with b squared is equal to 44. And again, we've got b squared, we want to know b, so we take the square root of b squared, and we get the square root of 44 comes down to about 6.6. So once again, since length cannot be negative, the height of the plane is about 6.6 miles. And that works because we've got 6.6, 10, and 12, and all those numbers seem very reasonable for the values that we're working with. So for this example, we've got Mr. Parsons wanting to build a new banister for the staircase. If the rise of the stairs of a building is 5 feet and the run is 12 feet, what will the length of the new banister be? So here we've got one leg at 12 feet and one leg at 5 feet. So we can just use our equation. So once again, a squared plus b squared equals c squared. We'll say a is 12, so we can say 12 squared plus b is 5. 5 squared equals c squared. 12 squared is 144 plus 5 squared is 25. That's going to all be equal to c squared. I add these up. I get 169 is equal to c squared. And then to get my final value, I've got c squared equals 169. I have to take the square root of 169 to get C. And when I do that, I get the value 13. So C is equal to 13. And yes, that does sound reasonable. Moving on to 3 here. We've got a 12-foot flagpole that's placed in the center of a square area. To stabilize the pole, a wire will be stretched from the top of the pole to each corner of the square. The flagpole is 7 feet from each corner of the square. What is the length of each wire around to the nearest tenth? So we've got a vertical measurement here of 12 feet and a baseline horizontal measurement of 7 feet. We're looking for the hypotenuse. So we've got, we're calling it AB, just a length. So we've got AB is 7 squared and AC is 12 squared. Work through the math. 7 squared is 49, 12 squared is 144. We get 193 equal to BC squared, which is, that's just stating the hypotenuse differently. We could name this line with one letter, which C, or we can name it as a segment, which would be BC. We get 193 is equal to BC squared. Take the square root of 193 and we get about 13.9 for the length of BC. Let's try one more. The top part of a circus tent is in the shape of a cone. The tent has a radius of 50 feet. The distance from the top of the tent to the edge is 61 feet. How tall is the top part of the tent? Round to the nearest whole number. So once again, we have to think about what we're given here. So we've got 61 feet. That's our hypotenuse, so that's C. We've got 50 feet. We'll call that B, and we'll say we're looking for A. So we write out our values. A squared plus B squared equals C squared. I don't know A squared or A, so I'm going to put A squared plus B is 50, so I'm going to take 50 squared equals, oops, C is 61 feet, so I'm going to say 61 squared. So now I start working through the problem. And 50 squared is equal to 2,500, or 2,500. And 61 squared, remember that's just the number times itself, so 61 times 61 is 3,721. To solve, I'm going to subtract 2,500 from both sides. And I get A squared is equal to 1,221. So now to get my final value, I have to take the square root of 1,221. And let's see here, get my calculator going. And when I take the square root, I get A is equal to 34.94, so round to the nearest whole number. I'm going to change that to A is equal to 35. Next, I'd like you to try just one of these problems. We did these in when we went outside and did our sidewalk chalk math, but just for a review, I'd like you to just take another look at either problem 1, 2, or 3 before moving on to the homework. And your homework assignment here, we've got lesson 6 skills practice. And what I'd like you to do is there's 8 problems, and I'm going to say pick any 6. So you can pick any 6 problems. And work on that for your homework assignment today. Please turn it into Canvas once you are finished.